So, hello everybody. Thanks for coming here tonight at this event. Just a couple of words before giving the floor to Vedra and Databricks about our community. So, for those of you who doesn't know Data Science Milan, we are an independent group. We have been done a lot of meetings, more than 100 meetups since 2016. So the aim of our community is to understand what does it mean to apply machine learning, data science, artificial intelligence on practice, on real use cases. So we managed to create this event with companies, startup, and large corporates, and so our aim, just to share information about this topic and of course to network. How do we do this? By once every 2 months about this meetup. This is our staff, so all of this is possible thanks to this. So if you want to create an event or manage an event with us, please reach out. 4 of us are here tonight, and all of our talk are available on YouTube and on our SlideShare channels. We are also available on LinkedIn and on Medium, where we summarize all our articles. And if you want to create an event with us, please talk with us or just send an email to this datasciencemilan@gmail.com email. And that's all for my side. So I leave the floor to Gabriele from Databricks and enjoy the event. But
okay, well, thank you very much to the data science community and to Vedra to host this event. So my name is Gabriele. I'm from Databricks, and today, in the next 15 minutes or so, we will deep dive a bit into what is Databricks and how it comes to bring assets as a data science application. So for the ones who never heard about Databricks, Databricks was founded approximately 10 years ago. And it was founded from the same creator of several open source projects, like the Delta Lake format or MLflow as a framework or library for machine learning, Spark, and this year DBRX model as well. And basically, Databricks has been known in the market because of the Lakehouse approach as a data platform. And this platform was released a few years ago, and today we will see what it is and how it has been improved in the years. But it was very well accepted by the market, and today we have more than 10,000 clients on our platform, and we have been also recognized, for instance, by Gartner as leader in 2 quadrants. So let's see what is the Lakehouse approach and how it supposedly brings value to our clients. Basically, the idea from our founders is since data and AI is becoming more and more important in all the let's say all the business applications. We have a lot of use cases, and generally behind all these use cases, we have dedicated platforms. So there are platforms really strong at doing data warehousing, then some other platforms dedicated to BI, or more recently to streaming and data science use cases. And having so many platforms in the end brings 3 kind of problems. So the data typically is siloed, and some applications may have access to it, some other don't have access to it. So in the organizations, different teams see different things. This also brings some concerns in terms of governance and security. And also every application has a little bit of specific technicalities. So also organizations need to hire experts in every area or on every domain. So the Lakehouse approach, there is a paper on it, but basically the idea starts from having the data stored in the cloud in an open format and generally in a cheap and high availability solutions like AWS S3, for instance. And this data stored there is read by the Lakehouse in an open format. There is then a unique governance layer. And then on top of these two pillars, we have the different applications like data warehouse, some features that are dedicated to orchestrating pipelines, some others to do data science, and others to do real-time analytics. So this, one important part of all this approach is that it's one single application that serves all the use cases we saw earlier, and it is built on open formats. So Databricks, without any specific connectors, is integrated with all the other applications that also use or are compatible with the same open formats. So basically, it's by just using open source formats, it will be easy to integrate it in existing architectures. And this year we released a lot of features and a lot of investments on the GenAI, which is also a trending topic. But basically, the idea is that this application can be improved, especially on serving features and functionalities automatically with the addition of GenAI features. And basically, starting from the Lakehouse model and adding some GenAI, we obtain a new concept of a data platform, which is the data intelligence platform. And we see now what does it mean. So we start from the Lakehouse. Now we see basically the same slides, but with the different namings that Databricks or products that Databricks developed in each box. So for instance, on the open format that Databricks chose is of course the Delta format. As a governance layer, we have Unity Catalog, and then the different other products like Databricks SQL, Workflows, Mosaic AI. But basically, starting from this, we added a data intelligence engine, which has large language models behind it. And it's basically across the application will serve extra functionalities with GenAI. And some examples, for instance, on the governance, we have automatic lineage from your data or automatic tagging of fields and tables. And also, for instance, you can look up your data using natural language. So you don't need to remember table names, but you can find your data using natural language. Another feature is that, for instance, the Delta Lake format has Parquet files behind it. And with GenAI, we basically automate the layout of this Parquet file in the optimal way, starting from your queries or how you use the platform. And we added also a functionality to do text to SQL. So also people who are not that technical or users that want to talk with the data literally, they can do it without knowing SQL. On workflows, so on pipelines, we have automatic auto-scaling or the choice of the cluster. So this is also optimizing the performance and the cost. Also in Delta Lake table, we added automatic data quality functionalities. And the last piece is also adding functionality to really build your own GenAI application. So from one side, we have functionalities to improve the platform usage, but on the other side, we also have functionalities to build your own projects in using large language models or GenAI. and also machine learning. And one example of this earlier this year was the creation of the DBRX model, which is a large language model that Databricks developed from scratch and released between March and April. And the interesting fact is that it was built all on Databricks, so using all the different functionalities we saw. It took some months of development. It took considerable investments, but if you compare it with other models on the market, it was really cheap in this area. So that when we released DBRX, we compare it with the existing models at the time, and it had great performances. So especially on programming and math, let's say KPIs, DBRX outperformed majority of the open source models. Of course, at the time, for instance, Llama 3 was not there yet. So these performances lasted like a few weeks, because then all the other companies also released better version of the model. But the important point for Databricks was not really to release a better model or the best model, but really to show what you need to build a model. So to build a very, to create a very complex project, like building an LLM from scratch. And the different components that Databricks used are mentioned here, but basically, okay, so we can start, but yeah, so basically the key features that Databricks used to build DBRX spans from like simple notebooks, using Spark, using Unity Catalog for governance. With Mosaic AI, we have some pre-built clusters technology to do the pre-training of these very large models with a lot of data, of course, and MLflow and Lakeview, basically to build the models, but also to experiment and monitoring the quality. And Lilac AI, for instance, is a company which provides features for data exploration and automatic features to work with natural language. And it was also acquired by Databricks in this process. And also open source libraries and foundation model APIs, of course, and the AI Playground, which is another Databricks feature. So as you can see, basically all the tools that are available to build DBRX are also available on Databricks by default. So it didn't need any specific functionalities developed ad hoc for this. And the key, let's say, the key lessons learned by Databricks in all this process is, of course, starting from a very good model architecture. The best architecture at the time that the DBRX was built was to use the mixture of experts to also serve the model with very good performances, despite having a very large architecture behind it. But also, for instance, the choice of a tokenizer matter in all the process. So to complete such a project, you also need a platform that allows to test, to track all the different metrics that you will have with different configurations. So in the end, Databricks chose to use the GPT-4 tokenizer, which is also open source. For instance, some strategies also on the pre-training approach were very successful, like curriculum training allows you to basically vary the mix of the data that you use in the different training phases. So for instance, DBRX was built using data available on the web, and during the phases, the mix of the data was varied. So some of the good sources, like for instance, GitHub, which is of course, showing in the performance on the programming for DBRX were upsampled, so more data from, for instance, GitHub, while other sources were downsampled, so less data from sources which are, for instance, less reliable than that. This was a winning strategy in the training. But most of all, the important aspect was the value of the data. So the data that Databricks used in this process was data present on the web, but it was cleaned and curated before doing the training. And just by using this data and training old models with old architectures, for instance, Databricks showed that the models perform better. So just by simply switching the data, you can achieve better results in those KPIs we saw earlier. And so here, if you're interested to know more about this specific point, there is on YouTube an explanation of all the different methods used to showcase this and the impact of the data. If you want to watch it, the video is shown there. If you want to take a note for this. So the idea is that, of course, you need basically a platform that allows you to achieve all of these points. So having the synergy with the data, having a platform which is accessible to basically experts in some domains, also non-technical staff like people with the business knowledge. You may want a platform, of course, simple to operate and with solutions to build your own AI projects. So that this is why Databricks was the platform where we developed DBRX. And if you are curious to know more about all these functionalities that we mentioned, also with labs and more demos about those, we have this event at the end of November in Milan. So you are welcome to register here, and we will meet you there. So for these 15 minutes, it was just an overview, a quick overview on Databricks. I hope you now have a better idea of what it is. If you don't have any question, I will leave the word to Ilias.
Any questions? Okay. Okay, so let's start with my presentation. So first, I'm Ilias Chava. I work with VDI for the last 3 years. Currently, I'm a lead machine learning engineer. In the past 7 years, I also worked for different companies in Italy, but also outside Italy. And I had enough experience with machine learning and data science in general. Also, I'm MLflow ambassador. MLflow, for people that don't know, is an open source framework built by Databricks and supported by open source community all around the world. Other things, I love cooking. So I think it's one of the most creative things that we can do. So maybe one day AI will do everything for us, but cooking is, I don't know, it's going to do something similar. Before going to the presentation and deep dive in the presentation, I want also to show exactly what is VDI. So VDI is an Italian startup that has as a product Y product, and it's 3 components. So the first component is the Y builder. When you client or company can map all the process map for taking a decision. For example, I'm a retailer. I want to have more revenue, so I will map all the decision, how all things are impacting the revenue. For example, cost of energy, salaries, sales, all the variables. And once I'm mapping the variable, the graph or the decision process map, I run a lot of simulations on other products, that is Y Simulator, that try to create all the data that are missing. For example, you put as variables this forecasting. This forecasting that you put, there is only the historical data, so we need to have also the future data. So we do that in Y Simulator. We create the forecasting on that variable of sales, for example. We try also to provide some external data for cost of energy, and we create a lot of simulations. That simulations will be stored in a big database for that client, and we can run on that database a lot of analysis. The product that run analysis and interact with the user is Y Explorer. So you can explore different analysis, different targets, different scenarios, create new analysis, for example, to know what are the impacts of some values, what if I maybe change the price of my product, what maybe it can be, for example, if the cost and energy reach some price, for example. So you can do all these scenarios and compare them and see exactly how they can impact your final objective, for example, to have more revenue or to hire new people or what else. So it's general, and you can build your problem, company problem, and Y provide you all the insights to reach your objective. So this is exactly what we do. Okay, after this business presentation, I can deep dive into technical stuff. So let's start by defining what is MLOps. So MLOps, it's kind of best practices to handle well the life cycle of model machine learning model. It starts by collaboration. So our responsibility is to enhance the collaboration between a different team, like, for example, DevOps, machine learning, data science, maybe user experience. And the first thing that we look at is to use the right methods, the right practices to enhance this communication. Once we can communicate all together very well, we can start by developing all together our machine learning models. And for that, we need to make some steps like model selection, features engineering, modeling parameter tuning, and as machine learning engineer, we help all our team to automate the maximum that we can automate. So once we achieve this goal, we can start packaging and integrating and building all our machine learning models for each product and deliver it to the production. So this is exactly the third key point about MLOps. In that point, the model is already in production. We need to be sure that it's scalable, maybe following some strategies, for example, maybe most cases like we're using auto scaling. And then once the model is scalable, people can use it. We need to monitor in real time if there is some drift, if the model has some kind of anomalies in real time, and be careful about that. And then it's a loop. So once we did it for the project, so it's another iteration. Each time we have new data, new models, new projects. So this is MLOps. Each company can have different architecture for the MLOps part. So in our case, we use Databricks, and we have different workspaces for each environment. So we have development environment, staging environment, and production environment. Each environment is a workspace. And in the development workspace, we are building all what that matters for developing a machine learning model. Then in the staging, we are putting the continuous integration pipelines. We are assuring that everything is working as expected. And then once we are ready, we deploy our models in the production workspace. In the production workspace, thanks to MLflow, for example, we can handle versioning of models, because a model is three ingredients like cookie. So it's data as ingredient and the instructions of the recipe as a model machine learning, like a machine learning model. And if changing ingredients or changing the time, for example, of cooking, it will impact on that model. So you need to handle very precise the model versioning, and you need to use different strategies, like, for example, canary strategy to deploy the model, maybe do some A/B testing in production and see exactly which model is performing well. And with Databricks and MLflow, we can do this part without managing the servers. So it's very important so that we have all the time to focus on the value. Another thing that MLflow do for us is the serving endpoints. So we don't not handle the endpoints for the inference or create some server. We know that in Databricks, we have kind of clusters that we can just put the model there, and it will be auto scale as some constraint that we can provide in the beginning. So that's it. This is exactly our life cycle. As I say, each company can have different architectures. It's not something that is similar in all companies. Now, let's talk about LLMOps. Okay, so what changed from MLOps to LLMOps? Okay, so lots of things are very similar, but there is some points that are very different. Okay, or maybe fair. So let's start by model selection. In case of machine learning or classic machine learning, when you start the project, you just like go to, I don't know, XGBoost, random forest, and say, okay, I will select this model, this model, this model, because I think it will be better, and then I will evaluate at the end the results. In case of large models, you don't start from scratch, unless if you are, I don't know, like Databricks, very rich. But usually you start by choosing pre-trained model. So you are Llama, GPT, Phi. There's lots of models in the list, usually built by big companies. And from there you start to feed your model by your data, and then you just make fine-tuning the model. In case of classic machine learning, you feed all the data from the scratch to your model, and then you have a new model trained from the scratch. Evaluating the model in classic machine learning, we use accuracy, F1 score, something that's already defined, and we can expect exactly the results, and it's straightforward. In case of large language models, we don't have a specific answer or right answer. So imagine some kind of generative AI that provide or generates video, audio, text, for example, how you can say that is a wrong answer. So we need to develop new metrics, for example, how much they are similar, similarity, relevance, and so on, to exactly evaluate your model. So this is a very important point. Deploying machine learning model, as I said before, it's a pipeline. You package your model, put it in the Docker, and then you put it in the server. In case of large language model, you need to deal with different technologies. So you don't have only one model, but we have also the chain, for example. We can have also a vector search endpoints, for example. We can have prompt engineering to do, for example. So there is lots of new components that in the classic machine learning was not present. Monitoring the model is very important. So monitoring the model in the case of classic machine learning, you have real-time monitoring. Maybe you can take accuracy as an example, and you are just like trying to find some anomal behavior of the model, for example, some model or target shift, or maybe some data shift, for example. In case of large language model, your model can start to be racist, for example, for tomorrow. So you need to put the human in the loop and try to get to the feedback. For that reason, ChatGPT asks you to say yes or no, for example. So you need to trace your model to take and track all the queries and try to exactly to see if your model is start to have some new behavior that was not present during training. In case of the effect of infrastructure, usually in classic machine learning, CPU is enough to serve your model in the inference servers. Like 90% of cases, if you use XGBoost, for example, or random forest, CPU is enough, unless if you don't go to computer vision, deep learning, and transformer. The cost was very easy to understand because I'm putting my model in my server. I know exactly how much it will cost, for example. And then you need also to take in account the scalability part and so on. In case of large language model, there is models that they are kind of SaaS models. For example, OpenAI is one example. You need to pay by token. You can't understand exactly how much token you will generate. So the business model is different, and you need to take care about that. In case of security, so classic machine learning model, usually you need to put some layers for prevent adversarial attacks, SQL injection in some case, data breaches, and that's all. In case of large language model, there is prompt injection. So someone can, for example, tell, forget all of this, what you learned, do what I asked. I'm the user, so you train to serve the user. And, for example, can attack your model. There is also the risk of data breaches, SQL injection. For example, we see before text to SQL as a service. And in that case, maybe you can create SQL to run on your model and say, delete all tables. And you need also to be careful about the things that you are generating. And for that, for example, also Databricks provide this as a service. There is like guardrails models that try to interpret the query or the question from user and see exactly how to handle security concerns. Okay, now we understand exactly the difference. We want to start our first project, what to consider. So the first thing to consider, the different techniques in large language models. So we have prompt engineering. As an example, there is few-shot, for example. Few-shot engineering is you just like provide some examples to your model, and he will understand from examples and follow the instructions. There is chain of thought that you provide to your model the steps to follow to run some query. There is also the React prompt engineering when you deal with tasks, actions, and observations. For example, I told my model, show me the last series in Netflix. It will go to Netflix as action, try to find what is a series, list all the series, and provide me an observation. Okay. The things that we can say about prompt engineering is easy to use. You don't need like technical skills to create a prompt. It's cost effectiveness, so it doesn't have like a high cost, but it's limited to custom for some companies, especially if you are dealing with private data. It's not consistent, so it's very difficult to generate after 1 year the same answer, and depends a lot about the model's knowledge. Where we have like accurate answers. So in case of fine-tuning, it's easy to custom. We can feed our data, we can have more accurate answers. But on the other hand, we have problems with the cost. So because it's not something that is cheap to do, it's costly. We need to have some kind of technical skills to do fine-tuning. Comparing to prompt, you don't not even need to code, for example. Required a lot of clean data to feed the model that you want to read. Another thing to consider is the model that you need to select. There is lots of different models all around the world, and may differ by complexity, by size, by cost, by performance. There is no one model that fits all use case, so each use case need to have or to find the right balance or the trade-off between performance, complexity, and cost. So once we understand exactly the field of LLMOps, let's go to make some demo and so exactly some application for that. So I look all around what the use case that can fit this meeting, and all what I found when I'm trying to using external data. This accepting time of service, because this data don't need to be fed by an AI model. So at the end, I start asking, in this case, Llama 3, for some requests. For example, I ask him, today I'm cooking, my grandma is coming, what I need to cook. And Llama provide me this recipe. I forward this recipe to my grandma, and she told me she's not coming. Why she's not coming? Because in the past, my grandma gave me a lot of Moroccan recipes for soups and as PDF files, and I didn't use that recipes. But it's not my fault, it's Llama's fault that I don't have this data. So what we are going to build is kind of a quick application to make Llama recommending my grandma recipe. And if we understand exactly the cases, the right case for recipe recommendation. To do that, we need to take my grandma recipes in offline mode, like in before, and chunks all the recipes. There is lots of methods for chunking, sentence splitter. There is also character splitter, and there is lots of methods that we can use. Each method can impact the final answer or the final accuracy. So we need to try a lot from this method. Once we have sentences from my recipes or my grandma recipes, we need to use some LLM embedding models to translate or convert these chunks to semantic features. So it's kind of vector that present exactly semantically the sentence, and if we have a mathematical space and put all this embeddings together, we can see exactly how much they're similar, and we can make some mathematical function, for example, how much is similar, for example, pasta to pizza, for example. Once we have all this embedding, we insert them in an embedding table, and Databricks provide these important things that make an automatic synchronization, the delta tables, and you can, in automatic way, update each time that you have new recipe, your vector search endpoints. This is fantastic. So what's we have in the online mode? So when I ask, or when I want to ask my Llama again, I want that he converts the query in embedding vector. Try to find the similar contents or context from this from this table. Provide this context to the Llama again, and provide me new recipes. That's usually my grandma have as expectation. So let's build all together the offline part. I will go very fast on the notebooks. Yeah. So this is in Databricks how we start by asking Llama. So I just use some community library, community code from Llama, from a LangChain, I'm sorry. And I choose the model, Llama, and then I ask him this question, the same that we saw in the presentation. Zoom. Okay. Così bene. No. And then to make this part of offline, so I just upload my PDF files, my grandma's secret PDF files that's very difficult to find in the internet, uploaded to Databricks volume in my catalog. Then I have this result. So this is exactly what I can find in the catalog: the PDF file, the name of the recipe, and the size of the file. Now I need to take this PDF and extract the text of the recipe. Once the text is extracted, like this, I can chunk it and using sentence splitter. I use sentence splitter from Llama Index library. And then once I have my chunks, so a complete sentence for the same recipe, I can make the embedding. And the final result is something like that. PDF name, context, that is the chunks, and the embedding vector that present the semantic features of this sentence. Once I achieve this offline part, Databricks provide Delta Sync that update my vector search endpoints with this data in automatic way. So I just need to tell them in this way, like create an instance of vector search client, tell them exactly to synchronize the embedding with the already created table, and the rest is done by Databricks. So now I can invoke the vector search and tell them exactly, for example, give me some Moroccan vegetarian soup recipes, and it will provide me some examples. Like this is the embedding. And once I get the embedding, I just go to this mathematical space or the delta table and provide me, for example, which are the sentences or chunks or context that is similar to my question. And we got, for example, these recipes or these chunks. And we got also score of similarity. Okay, so now we can invoke with vector search endpoints. We can give him like a sentence. He will give us the similar chunks or context, and give us also score. Maybe other, like, I didn't use this method, but I want also to show it. It's important. There is also some other libraries or ranking libraries that's not use usually the similarity to rank or order the context. They are using other models, for example, other metrics. And in this case, I want to introduce Flash rank that, given another model, provide you another ranking. Okay, so this is it. We can now go to the final application. So once we have the vector search, we can start by our question again and see exactly, given a different context, like the context, I mean my recipes grandma, what will provide as an example. Here I'm using MLflow to make all the parts of evaluation. So I'm using also LangChain for creating the prompt template. And when we ask him, he gave us exactly what my grandma is expecting. Okay, no, I think my grandma will be happy, but I'm not sure if exactly the model is performing well. So I start by evaluating using ground truth data that I already provide. For example, here I'm using just only 2 questions. I already write the right response, and I'm used MLflow with already native metrics already developed to evaluate the dataset. And the results is something like that. In this case, I'm using another large language model. In this case, I'm using MTP, if I record, to try to find or to evaluate the model and see if the response and the ground truth are similar and relevant. And I have this score, for example. It's from 1 to 5. Once I evaluate the model, I'm using, again, MLflow to track all the experiments, put all the parameters that I used in the log of the experiment, use also the artifacts that are the binary models, the embeddings models, everything, and package all my chain by the required libraries. In that way, I can ensure the reproducing the same experiments again. And what it creates this code is something like that. For example, if I go to experiment from here, I can show, for example, my notebook experiments from here. I can see exactly all the runs that I did in the past. I can, for each, this is the last run, I can see exactly the the data set that is for the evaluation. I can see here all the metrics that was locked. I can see here all the artifacts that I used, and so on. And the last things that is important, this chain is registered in my Unity catalog. In that way, I unified the models and data in the same catalog. And if I go here to the catalog of my grandma, I can find the models already registered. I can set an alias to this model. The last one, for example, I can say best model to production, or best chain to production. And I can save this alias and serve the model directly to the serving endpoints. Here I can decide exactly what I want to put as a GPU or GPU. I can see exactly the environment variables that I can set, how I want to scale, like from 0, or I have some concurrency already set. And the last thing that is very important, I can define also an inference table. So in that way, all the queries that will be invoked or use these endpoints will be stored in different table, and I can make monitoring in real time. Okay, so turning back to the slides. If we had more time, we can run the code, but I don't know if this case. Okay. So we already saw exactly how MLflow helps us to track all the experiments, log the parameters, log the metrics, log the table, dataset for evaluation, and the artifacts model. Once it's packaged the model, we have a YAML file that describes all the model, that describes all the outputs. If we have the YAML, we have the requirements, we can deploy it to production. We register the model in the Unity catalog, and that way we can handle different versions. Another thing that is important about catalog, you only need to build your model in one workspace. The fact that catalogs can be shared between workspaces, you can just copy the best model in other workspaces without training again your model in different workspaces. And here, like the last endpoints, so you monitor the latency, you monitor the CPU usage, the errors, the rate of success, and that's it. So let's go back to my problem. So I have a question, so I want to cook something for my grandma, and I ask again Llama. He gives me different answers, exactly what my grandma is expecting. So I forward to my grandma, and she's coming tonight. So I solve my problem. I'm happy, my grandma happy, we're happy, and that's all. We are in Bedlight also trying to make different use cases with the generative AI, with our client's data. And we are looking for new people, like machine learning engineers, product managers to help us. And if you are interested, maybe you can scan the code and follow exactly the link to make candidate. Thank you. That's all.